Hello, we're live. I'm Dylan, and welcome to Penang Science Cluster's STEAM Trivia. Last week was about tissue culture, and this week we'll be talking about electromagnetism and electromagnets. If you have any questions, please put them down in the comments. But before we get started, please prepare two devices. One for watching this stream and one for the Kahoot quiz later in this stream. Also, I do wish to mention that we have a Google Classroom which you can join and have access to additional materials that goes along with today's topic. If you wish to gain access to this Google Classroom, please go to bit.ly/Steam Trivia Registration. So, what is STEAM? It stands for Science, Technology, Engineering, Arts, and Maths. For those who just joined, welcome. We're talking about electromagnetism and electromagnets today. Let's get started. So when I say the words electromagnetism and electromagnets, what comes into your mind? Are you confused between electromagnets and electromagnetism? I certainly was. An electromagnet is a product, an item, while electromagnetism is the study of the magnetic force that is created with charged particles. The magnetic force being called electromagnetic force. We can use electromagnetism to explain how an electromagnet works. A simple electromagnet consists of a length of wire turned into a coil and connected to a battery or power supply. Here's a little story on how the study of electromagnetism began. In 1820, a guy by the name of Ørsted was giving a lecture on electricity. He described a ship that had been struck by lightning. Its compass was affected, so that its north and south poles were reversed. Ørsted was certain this proved the link between electricity and magnetism. Then a thought struck him. He could try an experiment there and then to test his idea. On his bench, he had a wire and a compass. He placed the compass under the wire, and when his assistant connected the wire to a battery so that a current flowed through the wire, the compass needle moved. At that time, no one was very impressed, not even Ørsted. But the more he thought about it, the more he realized that he had observed something significant. The current in the wire was producing a magnetic effect, which was acting on the compass needle. By moving the compass around near the wire, he discovered that the magnetic effect showed a circular pattern around the current. Cool story, right? And then there's this other guy called Faraday and the Faraday law. Heard of it? So from the story earlier, we know that a guy by the name of Ørsted discovered that electric current can produce a magnetic field. Well, about a decade later, this English scientist called Michael Faraday discovered that the opposite is also true. A magnetic field can produce an electric current. This fact is known as the Faraday's law. Let me repeat that, shall we? So, Ørsted, electric current can produce a magnetic field. Faraday, magnetic field can produce an electric current. So, what are the applications for electromagnets and electromagnetism? Electromagnets applications include but are not limited to wireless charging, maglev trains, electromagnetic lifting cranes, and magnetic resonance imaging or MRI. Let's delve deeper into two of these, starting with wireless charging, shall we? So, wireless charging or inductive charging is a technology that allows you to charge your phone without using a cable. The Qi standard is an interface that describes the transferring of electrical power via induction up to 1.6 inches. Qi is the official wireless device charging standard adopted by all major smartphone companies. To ensure that the wireless charging station doesn't power a nearby object, wireless power stations use tiny transmitters that communicate with small receivers in the phone. But while wireless charging currently is most commonly seen in our smartphones, wireless power may soon extend to many more applications. For instance, electric buses in South Korea can now be charged through a wireless platform. And IKEA, the furniture store, you know that, right? The big blue furniture store? Well, it's rolling out a new line of furniture, including lamps and tables with built-in wireless charging stations. And what about maglev trains? Have you had the opportunity to ride a maglev train? Now, normal trains use wheels that ride on rails. Maglev trains don't have wheels, and they don't use normal tracks either. Rather, they float over guideways. So, what are some careers that can apply electromagnetism and electromagnets? What comes into your mind? Well, technicians, engineers, product designers are just some of the many careers that apply electromagnetism and electromagnets. Product designers in particular use different tools to create a solution that solves users' experiences deficiencies. It's a combination of design, technology, and engineering. And for those who just joined, welcome. We're talking about electromagnetism and electromagnets today. And we shall now move on to our Kahoot quiz. Which you can now go ahead and join by going over to Kahoot, Kahoot.it, and you can enter the game pin when it asks you for the game pin. Our game pin for today is 5987230. Let me repeat that. The game pin for today is 5987230. So we're gonna give a few minutes to people to come and join our Kahoot quiz. And once you've entered the game pin, you can just click enter. So right now we are talking about electromagnetism and electromagnets, and we're currently transitioning to our Kahoot quiz, which you can join by going over to kahoot.it, kahoot.it, and entering our game pin 5987230. Once you have entered, you can click enter, and then you can spin, and you can just click on OK, go. And just wait a moment. And I think we shall now move on. We've given plenty of time for people to join. So, first question: which of the following is an application of electromagnets? Is it A, magnetic resonance imaging or MRI, B, maglev trains, C, wireless charging, or D, all of the above? And if you answered wireless charging or you answered magnetic resonance imaging, you're not wrong, because they're all indeed applications of electromagnets, but the correct answer is all of the above. So moving on to our next question. How do you increase electromagnetic strength? Is it A, increase the number of coils to the coil wire, or B, increase thickness of wire? Well, it's indeed increasing the number of coils to the coiled wire. If you remember how a simple electromagnet works, we coil a wire, and basically with electromagnets, it's all about coiling of a wire. So this is our leaderboard with some action. Polite Lizard is at the top, followed by Rocky Ostrich, and Giving Horse is runner up. All right, so let's move on to the next question. There is a limit to how much current can be passed safely through a wire due to the different fill in the blank of the wire. Is it A, current, B, resistance, C, induction, or D, flux? The answer is resistance. So flux is a rate of electricity through a given area. Induction is the production of an electric force, and current is the rate of flow. And with resistance, it's best explained by this simple analogy. What you get out of a wire is probably less than what you put in due to resistance. So we got some moving of the scoreboard. Giving horse is the number one spot, followed by Rocky Ostrich and then Mystery Possum. All right, keep bringing in the answers, and we're going to be moving on to the next question. Wireless power stations use tiny blank that communicate with small receivers in devices. Is it A, transistors, B, transmitters, or C, switch? The answer is transmitters. So transmitters transmit, a switch can break a flow, and transistors can switch or amplify. And as the explanations would suggest, a switch or transistors is not the ideal component to communicate with small receivers in devices. Check out the scoreboard. Again, we've got a different positioning of players, with Rocky Ostrich taking first place, followed by Giving Horse. And in third place, we have Green Ferret. Keep the answers coming. Next question. What is the official standard for wireless charging? Is it A, Qi standard, B, Qi standard, C, Omega standard, or D, Beta standard? And the answer is Qi standard, spelled with QI. It's unfortunately not spelled CHI, and it's definitely not Omega or Beta standard, sorry. And let's check out the scoreboard. Giving Horse has an answer streak of 5, meaning that he or she has answered 5 questions correctly continuously thus far. Congratulations, and you're in first place, followed by Greenfell, and Diligent Shark is in third place. It's good to see the leaderboard shaking up. And moving on to the next question, we have wireless charging is an application of Faraday's law. Simple, true or false? Remember the story we mentioned at the beginning of the stream? It is indeed true. Faraday's law, if you remember, was that he discovered that a magnetic field can produce an electric current. And now we shall move on to the scoreboard, which is the exact same as before. So congrats to the people appearing on the scoreboard. I do want to mention that the faster you answer the question, the higher the score you can possibly obtain. Next question. Wireless charging uses a loop of blank wires around a bar magnet. Is it A, straight, or B, coiled? The answer is coiled. I want to repeat myself again. With a simple electromagnet, we coil the wire, and basically with electromagnets, it's all about coiling of a wire. Okay, moving on to the scoreboard. Again, no change to the positioning of the scoreboard. It's alright. Those who haven't appeared on the scoreboard yet, don't worry just yet. You still have a chance to, come onto the scoreboard. So coming on to the next question. What is not an obstacle in making wireless charging available everywhere? Is it A, overheating problems, B, slower charging speed, C, higher cost, or D, inconvenience? And the answer is inconvenience, because I shall repeat the question. What is not an obstacle in making wireless charging available everywhere? If this question was restructured, reworded to be what is an obstacle in making wireless charging available everywhere, then overheating problem, slower charging speeds, and higher cost would then be correct. It's all right. It's all right. We do get things wrong from time to time. And the scoreboard has moved, but same five people as before. All right, all right. It's pretty interesting. This is moving on to our next question, which is also the final question. Which of the following is what product design engineers do? Do they design new products, create solutions for problems, improve products, or all of the above? The answer is indeed all of the above. Again, if you answered design new products, creating solutions for problems, and improving products, you are not wrong. Product designers, in particular, design new products and create solutions for problems, improve products by using different tools. And this is our scoreboard. Ooh, finally some repositioning of players. We got Diligent Shark at number 1, Green Ferret in 2nd, Smart Kitten, haven't seen you on the leaderboard. Welcome to the leaderboard in 3rd place. Polite Lizard in 4th, and Giving Horse in 5th. Now this next question, you don't really need to answer. It's not going to be graded. It's just for verification purposes to claim your prize. So what would you name a dragon? Good question, right? For me, I would totally name my dragon Electromagnet. Isn't that just cool? And we got a variety of interesting options and choices, and well, and this is our podium. In 3rd place, we have Smart Kitten. Congratulations. In 2nd place, we have Green Ferret, and in 1st place, we have Diligent Shark. Indeed, a very diligent shark, huh? Anyways, for Diligent Shark and Green Ferret, please go to the comments section later and open up a Google form that will be posted into the comment section where you can fill in some particulars to claim your prize for being 1st and 2nd of this week's Steam Trivia Kahoot quiz. And that's a wrap on this week on electromagnetism and electromagnets. Thank you very much for joining us. Please go ahead and follow and like Penang Science Cluster's Facebook page. Share it with friends and family. Next week, we'll be talking about motion. And lastly, thank you to the American Embassy and ATC American Tech Corner for supporting us. Sorry, a bit of technical difficulties right now. I'd just like to reword the last sentence I just said. Lastly, thank you to the U.S. Embassy and American Tech Corner for supporting us. And now I believe I can say bye. Bye bye.